A very good morning, students. This is your teacher Neelam Helawat, and today we'll continue our chapter, that is the chapter 1, Chemical Reactions and Equations. And I hope you are revising this chapter thoroughly along with me, right? I hope your revision is going on smoothly and there is absolutely no doubt in any of the questions. Even if you have, kindly contact me on my personal number. I'll surely solve your queries. Okay, everyone? So let's proceed with our revision. Yesterday we were talking about the types of reactions, and we have generally spoken about, and we'll start with the topic corrosion. So corrosion basically means, students, that it is a slow eating away of metal in the presence of air and water. Okay, it is a slow eating away of metal in the presence of air and water. So air and water, both these things are required for the corrosion to occur. And the formula of rust is Fe2O3 dot XH2O. So this is the formula of rust, Fe2O3 dot XH2O. Now corrosion, it weakens the metals. Okay, everyone, it weakens the metals. That is why we need to prevent the corrosion. Now this corrosion term, in case of iron, we use the term rusting. Especially in case of iron, we do not use a corrosion word. Corrosion is a bigger term and we use it for all the elements or the metals together. But rusting is a word that we generally use in case of iron. So rusting of iron, we say it, right? Then how can we prevent corrosion? So corrosion can be prevented by using number of techniques. The very first and simple that we do is painting. We can easily paint the iron articles. Then we could go for oiling, greasing. Galvanization means we can coat it with zinc. Like if we coat any element with zinc, so zinc is more reactive than particular element, so zinc will react with oxygen and that metal will be prevented from rusting or corrosion. Then again we can use the aluminium for putting a coating, and this process of using aluminium as a coating over the metal, this is called anodizing. So we can use another method which is called anodizing. Okay, so we can use painting, galvanization, oiling, greasing, anodizing, right? These are the methods by which the corrosion and rusting can be avoided or it can be prevented. Next is rancidity. I hope you remember that if you keep your food stuff outside, like if you forget to keep your milk outside in the summer season, obviously it'll ferment, right? So we generally keep our food materials during the summer, especially in the fridge, so that it is prevented from rancidity. So what do we understand by the word rancidity? Rancidity means oxidation of fat and oil that are present in the food, okay dear, that are present in the food, and if they are left open, okay, so it is oxidation of fat and oil that are present in the food will result in into a bad smell and taste. Now suppose if you are eating, you can say you were eating kurkure, you open the packet and you left it outside. So after a few hours you will find that the kurkure it loses its crispiness, okay, and it starts smelling bad. So this is called rancidity, and that is why these packets which are sold in the market, like your namkeen, isn't it, your the kurkure and all other stuff, they are packed with nitrogen gas. Dear students, they are packed with nitrogen gas because nitrogen is an inert gas and it does not react with any food component. Okay, it does not react with any food component. Okay, that is why the industries, they use nitrogen for their packing their materials. Now apart from this, we can use vacuum packing. We can you can say keep the food stuff in the fridge, or we can keep the food stuff at a lower temperature so that it is prevented from turning into rancid. Apart from this, there are certain substances which are called antioxidants. Have you heard this term, everyone? Antioxidant. Have you heard this term? Antioxidant. Antioxidant means the substances which prevent oxidation of food. Okay, antioxidant means they are the substances which will prevent oxidation of food. So they can also be used for preventing the rancidity. Like for example, you can take sodium bicarbonate and you can add it into the milk. So this will prevent the milk from fermentation. So antioxidants, the substances which prevent oxidation of food. Now this is a very important activity, students, and this was generally asked in the board exams. Suppose you have copper carbonate, copper oxide. Okay, you have copper oxide. Now when you keep the copper oxide in the china dish, see, just observe the color. What color is that? Just tell me, what is the color? It is brownish in color. So when you heat it slowly, you will find that this color changes to black. Okay, when you heat it, copper oxide, it is of black color. Copper oxide, the color of copper oxide is of black color. Okay, but slowly, and when you heat it, it suddenly changes into brown color. You can easily observe in the china dish, it is now of brown color. So copper oxide is of black color, right? And when you heat it, it turns brown. So why this happens? Now basically, when you heat copper, which is of brown color, it combines with oxygen and forms copper oxide, which is of black color. Right, everyone? Which is of black color. So copper is of brown color. I hope you have seen it. Copper is of brown color, and when you heat it, it turns copper oxide, or when you leave it in the air, then it becomes black in color because it gets coated with the you can say oxide or copper oxide layer. But when we heat it, as I've taken here, we are taking copper oxide. So copper oxide is black in color. So when you heat it, okay dear students, when you heat it with hydrogen gas, then the copper is removed and water evaporates. Okay, water which is there, it will evaporate. So copper oxide turns into copper, and thus the color changes from black to brown. Okay, the color changes from black to brown. So sometimes they ask you, how can you convert copper oxide back into copper? So we can easily convert copper oxide into copper by combining with hydrogen gas. Okay dear students, by combining with hydrogen gas. So if you have a copper powder and you heat it, then the color will change from brown to black. And if you have copper oxide and then you heat it with hydrogen, then the color will again become black to brown. Okay. Now let's see this. I hope we have talked about the oxidation. So oxidation means addition of oxygen, removal of hydrogen. And I hope you remember. So I'm doing an example with you, right? Now suppose, just look at this. We have copper oxide and hydrogen. So copper oxide is reacting with hydrogen, and here you have only copper. So just compare the copper itself on both the sides. Just compare the copper. Just see this, everyone. It is here copper oxide, and here it is only copper. So here it is having oxygen, here it is not having oxygen, means it has lost oxygen. So copper oxide is undergoing reduction. Okay, copper oxide, it is undergoing reduction. Now here just compare hydrogen and you have water. Now here it does not have oxygen, here it has oxygen. So hydrogen is gaining oxygen. Okay everyone, hydrogen is gaining oxygen and it is forming water. So hydrogen is undergoing oxidation. Okay, so copper oxide is undergoing reduction and hydrogen is undergoing oxidation. I hope you remember everything, the concept, right? Now we can do the next example also. Just compare zinc oxide and zinc. Here you have oxygen, here you do not have oxygen. This means the zinc has lost oxygen. So zinc oxide is undergoing reduction. Okay, zinc oxide is undergoing reduction. Carbon here and C here. So on this side it does not have oxygen, here it has oxygen. So carbon is undergoing oxidation. Carbon is undergoing oxidation, right everyone? Yes. So I am giving you third equation. You can practice this equation also. Okay, clear? I hope you're clear with oxidation and reduction. Right. Now this is again a very important question. I am taking it especially because this is generally asked in the exams. Okay, the question is, why does the color of copper sulfate solution changes when iron nail is dipped into it? Just look at the picture. I have shown both this is your iron nail, this is your copper sulfate. Okay, now put it in the solution. This is your copper sulfate solution and this is your iron nail. Okay everyone, so we will put iron nail into the copper sulfate solution. Slowly we will observe that the color fades away. Okay, and the iron nail, it becomes brownish in color. So observations are that first, the solution of copper sulfate, it fades, color it fades, and secondly, the color of the iron nail changes to brown. So why this happens? So during this reaction, when iron is reacting with copper sulfate, Fe is iron, CuSO4 is a copper sulfate. So when iron reacts with copper sulfate, it forms iron sulfate and copper, and the color of iron sulfate is greenish in color. Okay, so in this reaction, the iron is displaced or removed. Iron has displaced copper because iron is more reactive than copper. So this reaction is generally called as displacement reaction. What do we call this, dear students? Displacement reaction. Okay. Now coming to your homework, all of you will revise this chapter 1 thoroughly. Absolutely, there should be no doubt in this chapter, right? So you got to revise all the question answers, all the concepts of chapter 1, right? Okay.